Friction is a phenomenon that hinders the relative motion between two bodies. Its origin is to be found in the fusion of their contact points. During the motion, these welds break and recreate, thus hindering the relative movement. In particular, static friction is a force that tends not only to hinder but to prevent the relative motion between two bodies, within the limits of how much this force allows. Let's take two bodies that we put on each other. In this case, we have got an horizontal guide and an object of which we can measure the mass by means of a balance. In this case, is more or less 600 grams or a weight of 5.9 Newton. Leaning the object on the guide, we notice how it remains in equilibrium, as there's no relative motion between the two bodies, since we are not applying any external force, and the body is in equilibrium. In this moment, the static friction force is zero. We will measure the position of the object during the experiment by means of this sonar, in order to see precisely if it moves from the equilibrium position. We will apply an external force to the object in order to move it, and we will measure the force by means of a dynamometer fixed to a sliding cart in order to move it easily and without adding friction. This dynamometer shows a negative force in case of traction and a positive force in case of compression. Let's start pulling and see what happens. For a certain 10 laps, even increasing the force, the object continues to remain in equilibrium, and we can see it because its position doesn't change. This implies that the horizontal force is zero. This means that, according to the principle of inertia, the external force is equal and contrary to the static friction force of the body. However, this situation doesn't remain forever, because at a certain moment, for a particular value of the external force, the object starts moving. We can better evaluate what is happening if we look at the graph of the applied force over time and the position of the object. As long as the external force is small, even increasing it, we do not notice any movement of the object. But if the force exceeds a certain limit value, in our case is equal to 2.7 Newton, in that instant the object starts moving. This means that the static friction force is opposed to the external force we are applying, but this happens until a limit value. The ratio between the maximum value of the static friction force, 2.7 Newton, and the contact force between the two bodies, that is the weight of the object, 5.9 Newton, is called static friction coefficient, and our experiment is equal to 0.46. This coefficient depends on the materials of the two bodies, both the plane and the object, but doesn't depend on the contact force between the two. In fact, if we double the weight of the object, doubling its mass from 600 grams to 1,200 grams, and we repeat the experiment, we can see how the maximum value of the static friction force is doubled from 2.7 Newton to 5.4 Newton, and therefore their ratio is unchanged.